This is another voiceover of the Stat 300 series of videos. This video is about the interpretations of probability. And to think about that concretely, we are working with the simple, or not so simple, experiment of rolling a bowling ball down a lane in 10-pin bowling and looking at one specific outcome being a strike. We can think of this as a random outcome if we think about um, the person who's rolling the bowling ball. We know nothing about their skill level, whether they know the rules of the game. Um, just we're interested in observing whether or not they knock down all 10 pins, or some of them, or not any at all. But the specific outcome that's interesting to us for now is whether they get a strike or not. So the most simple way to think about probability is that we can roughly think about it as the likelihood of obtaining a random outcome. So likelihood and probability we're going to use interchangeably as words. We'll also say chance, but that has a slightly different meaning as we'll discuss later on. There's three generally accepted interpretations of probability that we'll explore. The first that we'll consider is subjective. So when we think about subjective, we typically think that it means, just subject to somebody's personal opinions and biases. We don't mean anything pejorative here. All we mean is that we think about the specific event that we're interested in, the outcome. And there's all sorts of prior knowledge and information that we can take to understand whether or not that strike is likely to happen or not. So, there's the direction of the ball, there's the ability of the person who's actually rolling the bowling ball, the context. So, are they playing for fun? Are they playing for specifically to get the strike? Is it a good bowling lane, or maybe it's a warped bowling lane? And our knowledge of outcomes, right? So what is likely to happen? What have we observed in the past that will indicate to us what might happen here? And subjective probability, at least at this level, we're not going to have too much precision with that interpretation. We'll typically just use qualitative descriptors, things like there's a high probability of getting a strike, or low, or we would say that an event is likely if it's more than 50% chance of it happening. So more than half the time, that's something that we might call likely. Subjective probability actually is a interpretation that we'll be using in tandem with the other interpretations, just as much as we use more mathematical descriptions. It especially comes up again when we talk about inference, because we are going to be relying quite a bit on our prior knowledge about the situation. A second interpretation that we'll explore, which we kind of already have talked about, is the frequentist interpretation. So frequency, what that means is we're going to be looking at an experiment and the number of times that random outcome occurs. So we have already kind of explored this in the previous video, where we repeatedly simulated the dice rolls. And in that example, right, or more accurately, in this example, we can think of, each time the same experiment is carried out, the rolling the bowling ball and seeing whether you get a strike or not, that capital N is going to denote how many times we repeat this. So 100 times, 1,000 times, 100 million times, as large as we need to get a good clear picture about what we are observing. So how we interpret frequentist probability is we take the number of times that outcome is obtained, so the number of strikes we see, and we take that as a proportion out of the number of repetitions of this specific experiment under identical conditions. And that's what we're going to call the probability. So it's a ratio. And you'll notice that if you think about, how those two numbers are related, you are going to get that this probability can't be less than 0, because the least number of times that the outcome can be obtained is 0. And it can't be more than 1, because the maximum number of times you can obtain that outcome is the number of repetitions that you do. And so lowercase p sometimes denotes probability for us. And what's really interesting about frequentist interpretations is that the larger the sample size, or the number of repetitions, the much more accurate our frequentist interpretation of probability is going to be. So that p-value is going to be much more precise the larger number of rolls. Our last interpretation is the classical probability, where we are relating it more explicitly to the language of sets. In particular, what we're looking at is we're going to take an experiment and an outcome that we're interested in, and we're assigning to them sets. So specifically, an experiment is associated to a sample space, which we denote capital S, and an outcome is tied to a specific event A inside that sample space. So it's a subset. This is not, it is not going to be incompatible with what we've already explored. In many ways, it is just making more precise, or making more assumptions to make our probability more precise without resorting to number of repetitions. So the way we calculate this probability is we take the number of ways we can obtain A, and then we'll explain what that means in a second, and take that out of the number of total possible simple outcomes. So each individual outcome in our sample space, that proportion is what we'll take to be the probability. And it actually abides by the same rules as frequentist probability. And there's typically a simpler way of writing it, especially if we have discrete outcomes. So outcomes we can observe one by one. We take the size of this set A divided by the size of the set S. So it's a relative size proportion, essentially what we're exploring here. And we'll be able to use our mathematical tools much more easily here. So finally, how are these compatible? How do these match up? How do they align? Our probability of obtaining a strike in the subjective probability interpretation is, it depends on the skill level and your environment. And that will give us an estimate for that probability. Our frequentist interpretation would say that we take the number of strikes that we observe out of the number of bowls total. And lastly, our third interpretation, the classical interpretation, would say we divide the number of ways to get a strike by the number of total possible simple outcomes. Now, with the specific example we've selected, getting a strike, there's all sorts of different individual outcomes we can look at there. That's much harder to quantify than what we will be working with in this class in particular.